I'm Dan Siewiorek. I hold a joint appointment in electrical computer engineering and School of Computer Science, in particular the Human-Computer Interaction Institute. I've been at CMU 47 years. Well, one of the things you have to understand is I revolve around. So in the 1970s we did multiprocessors, 1980s we did computer-aided design, 1990s we did wearable computing, aughts we did basically context-aware computing. Now we're doing virtual coaches. So the first time I got involved with AI was back in the 1970s when we were doing computer-aided design, and there was something called layout. In other words, what you want to do is lay out a printed circuit board, or you wanted to route a printed circuit board. And at that time there were these blackboard architectures, and there were these rule-based systems, and we actually created a rule-based system that they had something called a switch box, where you have four sides and you have things entering and things exiting, and you want them to connect without crossing over. And so we actually did a multi-user expert system on that, and including a common sense expert that says when nobody else can move, everybody move one step into the center. And we were actually able to route things that were claimed unroutable in the literature. And unfortunately, it didn't really take off commercially because the rule-based systems were slow. Once they figured out what our competition figured out what they were doing, they could hard code it a lot faster. So much to Alan Knowles, to his chagrin, we didn't get as much press from it for what we did compared to another West Coast university that just hard coded it up and treated it as their own. But anyway,
it'll remain unnamed.
Yeah, and but one thing that we found out when we were doing the computer-aided design was that most of the AI researchers did what we call shallow systems. So another thing we were doing was basically laying out an integrated circuit chip. And MIT had a system that had a 300 rule-based system. And we took an ECE student and who had worked for AT&T, I think, one summer, and he did a system that had 3,000 roles. And it seemed to be the AI researchers would stop about an order of magnitude short of what you needed in terms of knowledge to really make it a viable, competitive tool. So anyway, that was just sort of a little anecdotal observation at the time. So that was the first encounter, but then we went on and did a lot of things with computer-aided design. We probably created what was now called a silicon compiler, where we could take a description. So this is a really good example of Raj Reddy's influence. So in about 1980, the Robotics Institute had just started, and they were trying to use computers to control robotic arms. And Raj always needed something that was bigger or faster than what he could buy. So he wanted something that had twice the memory, but it took 6 months to get it done. So he said, "Why can't you do that in 10 minutes?" Well, we did it in 10 minutes, but it took a year, 2 PhDs, about 4 masters and 6 undergraduate degrees to do it. And we actually created a company called OmniView, and we were actually able to take the type of specification you get from the back of a product brochure, like which was the processor, what was the clock speed, how much memory, what type of I/O ports, how long did you want the battery to last, system reliability, cost, and we could literally do that in about 10 minutes, get part list and net list, then go into an optimization phase that would actually cut the resources in half. But the problem is we started a company, and the students were involved with the company. Unfortunately, we were way too far ahead of the field. At the time that we were talking about doing synthesis, less than half the companies were doing even simulation. And so it's one of the times that the research can get out too far ahead. But anyway, that was sort of and a lot of these projects we actually wrote books about. So there's a book about the Micon project. So then we wanted to demonstrate that Micon could actually build things and interesting things. So we decided to create, we had an engineering design research center funded by NSF at the time, and we had an industrial affiliates program. And so we had about 20 people from industry coming for 10 weeks during the summer to learn about design. So we decided we didn't want to just have them sit and lecture for 8 hours a day. We wanted them to design something. And so we ended up designing what became our first wearable computer in about 1991. And this is what it was. So the students, we actually synthesized the electronic board by Micon, and then we worked with some design students who worked with people from industry to come up with the shape of the structure. You wore it over your shoulder like a man purse, and you rest your hand on the outcrop here. The buttons had different feel, so you could use them without looking at it. And it's very interesting. We actually made 30 copies, so everybody in the class went home with one. And we thought it was just a demonstration of our computer-aided design system, but when we showed it to people, they came up with all kinds of applications for it. And so that started our wearable computing. So for about a decade, we built about 20 systems, including systems for bridge inspectors, systems that did welds for nuclear submarines. We did maintenance for Marines at Camp Pendleton. We got them out in the field. We worked on F-14s at Warner Robert Air Force Base. So we got probably about 20 different systems looking for the repeated patterns, much like the desktop was driven by PowerPoint and Excel and word processing. And we came up with those repeated patterns. It's kind of interesting now that we're starting to see these wearable computers with these head-mounted displays come out, and we're starting to see them rediscovering. It's not the Google Glass, which was meant to be a social thing, but helping people with manufacturing and things like we learned we want to put it down. Our display at a place you could just glance at it for your information, but your attention was still in the real world. You're just getting your instructions of what you're manufacturing or what you're in the warehouse picking and so forth. So all of that started coming out, but just a little footnote of that, sometimes you transfer things by software, sometimes you transfer things by designs, but we transferred a lot of our stuff by people. So the first wearable computing company, Body Media, was spun out of our group, and the John Siewiorek and Chris Kasabak worked on these projects. Matter of fact, probably the first computer that Chris Kasabak did this one, and then this one was done by John Siewiorek. And you can sort of see this is not your typical square box, and
It's not.
it had a lot of character to it. The metal was sort of a heat sink, and this is a one-dimensional mouse. So everything on your screen was in a circle, and then you could select it. And if you're right-handed, you got this button. Left-handed, got this button. But so we actually put that out in the field. It actually won an International Design Award, although the design jury missed the point. They said it looked almost good enough to work, even though we had it out in the field working it.
What year was that?
This was 1993.
Okay.
So if you take a look at what's coming out now, Google Glass 2 and so forth, it's sort of this technology. So if you want to look at where things are going to be in 25 years, look at the university's research. But anyway, we ended up transferring knowledge by people. So John basically his company got bought by Jawbone, and now he's inside of Google X, leading their design team, because, quote unquote, he's been doing it for 20 years. Well, the two engineers who did the electronics inside of this, they started a local company and they did the first 5 generations of Fitbit products.
Okay.
And then an only in Pittsburgh thing, one of the 2 founders of Fitbit was my older daughter's senior prom date.
Oh my goodness. A family affair of sorts.
But anyway, we obviously, so a couple other things. We did our first smartwatch in about 2003.
Okay.
Which is about 10 years before other people came out with smartwatch.
That's right, yeah.
And we had a microphone, accelerometers, and light sensor, and we could actually use machine learning algorithms to decide what room you're in. Turns out this room has a sound and a light fingerprint, which is different from other rooms. So we could tell if the student was in their home or on the bus or in the grocery store or in their office or at lunch, just by the signature of the physical activity as well as the light and sound background. And so that was a good 10 years before. And then this device, we were working with Compaq, which was the old Digital Equipment Corporation, and they built something called the ITSE, which was this top part here, which had a touch screen and had accelerometers and so forth. And we added Wi-Fi to it and a battery. And you could consider this the first smartphone in about 1999. It had the functionalities that we take for granted in a smartphone. A little bigger, but
A little heavier.
but that's what happens when technology has a chance to take hold.
Right.
So anyway, so that's where we started getting into the context-aware, using sensors and then machine learning algorithms to figure out, first of all, what you're doing, and then where you were and other elements of your context. So now we're working on what we call virtual coaches. So the wearable computer got data out to where you're working and became portable. And then the sensors meant it became aware of your context. Now giving guidance to the user, closing that feedback loop, is the virtual coach. So we first started out with the virtual coaches with people who were doing exercises to recover from stroke. So the company called Myomo, or MyoMotion, actually had sort of a arm brace that had a motor in an elbow. So if you're trying to, if my right side is affected, I perhaps can't do something like bring a cup to my mouth. But I can do that with the therapist's help. But the therapist is only there for 6 weeks. And then after that, it takes a while. It takes at least 6 months before you retrain your brain. So MyoMo is to give a sort of power assist. So what we're trying to do is use things like Connect to watch a person doing their exercise to try to decide if they're doing it correctly. Well, first of all, are they doing it at all? And then are they doing it correctly? And so we actually created some games, like the fishing game, to bring a cup to your mouth. You would wait for the fish to get near the hook, and then you bring it up to your mouth. Well, we started some work with Portugal. There's a Portuguese CMU joint degree. And so we started working with them, and they had access to stroke survivors. And so we were doing some exercise. So just the straight exercise as fast as you can do about 600 of those a day. And that's what it took to really train your brain. Now, our virtual coach did about 450, but when we did the game, only 300. And it took us one of these moments you said, duh. Well, the duh was that there was a game situation. You had to wait for the fish to get near the hook before you could pull it in the boat. So that cut down the repetition rate. So now we've been working with Flappy Birds and other things like that require sort of, let me say, constant motion to keep the repetition rate up. So the other thing that we did was now we're working with a research institute in Northwestern in Chicago to help people who have getting prosthetic limbs to practice using the limb before they actually get it. So what happens is, there's a sleeve that senses your muscle movement, and so we put person basically in a virtual world where they can now control something like a shopping cart and picking things, or doing Flappy Birds if we want to go left and right and so forth. But the idea is to get them used to using their muscles before they get the limb, because when they get the limb, if they haven't been able to practice controlling it, their motivation goes away, and they never end up using the limb at all.
Yeah.
So they're supposed to be on the order of, we've got about a dozen games and half a dozen virtual reality games, and there's a VA hospital down in Texas that is going to try to use these with people who are about to get their prosthetic limbs and see if the games really help them get engaged.
Yeah, I mean, this is just an extraordinary cross-section of projects.
Well, yeah, it's one of these things, if you ask me where I would be in 10 years, I couldn't tell you. I can tell you the path I came.
Yeah.
But it's always sort of seems to be a serendipitous thing, a Raj Reddy coming by, or somebody's offering you a challenge, why don't you do this, and you start thinking about it. And well, I mean, I was always that October sky kid. 1957, you go out in the backyard and there was Sputnik. And everything and anything in NASA was, I gobbled that up, and sort of said, well, I don't know what engineering is, but I guess I want to be one, and got into engineering. And just do a little footnote, though, my dream job was to work with NASA, and actually my senior year in college, summer job was working for NASA up in Cleveland, and it's now Glenn Center. Well, I actually have a telegram from Glenn wishing me luck on my ear surgery. My parents, I don't know how my parents worked it out, but they're from Ohio, and Glenn was from Ohio. But so anyway, it's NASA Glenn now. But so we were actually working on the supersonic transport, and they had the high-speed wind tunnels, but the shock waves off the tunnel walls would corrupt the data. So they're going to do high-speed runs over Lake Erie with a Delta Wing fighter. And halfway through the summer, I got laid off. Oh. So summer interns got laid off with the Gardner's Net. It was 68. Apollo was just about, winding down, even though they still hadn't gotten to the moon. But, and so at that point, I decided that maybe NASA wasn't stable enough for a career. But so luckily that drove me to computing and made up my mind what I wanted to do.
Yeah, so it sounds like most of the influences were in the real world.
Well, yeah,
and pushing the boundaries of the material world.
Yeah, I think that's a good observation. I like to build things, and you like to get them out there and doing something. And I don't like to just build something to build it.
Yes.
You want to do, hopefully you're serving some type of need. Whoa. Real challenge. Let me divert that by giving another example.
Great.
So the wearable computer, basically for each of these decades, we would wrap up what we learned in a textbook, and usually try to transfer the technology, often starting a company. So we did start a company based on wearable computing in the early 90s, mid 90s, called Humanities, and we actually picked aircraft maintenance because it was a high value thing. Like at that time, US Air had a maintenance hub here,
right.
And if they had a fully loaded airplane that they weren't pushing back, they're losing $1,000 a minute. And in those days, head-up displays were like $5,000. So you weren't going to do that sort of commercially. I mean, for the general public.
Right.
But something like aircraft maintenance and everybody had the same problem. They had a 10,000 page manual, and you only needed 2 pages, but how do I find the right 2 pages? How do I share knowledge? Somebody's fixed this problem before, what is it, and so forth. So we created software that was called Interactive Electronic Technical Manuals. So literally every aircraft is unique. It comes out 200 built alike, but they come in modified different times and so forth. So what they had is a paper library with huge books, and then you had all these inserts that if you wanted to look at your airplane, you put these inserts here and so forth. Mm-hmm. Well, that was just ready made for electronics and a computer. So anyway, we eventually had a whole F-18 fleet in the world using our interactive software. And then finally, Boeing wanted to commercialize that for the commercial aircraft. But from that beginning to being bought out by Boeing was 17 years. Uh-huh. So this is not your hockey stick, Silicon Valley. I mean, during 17 years, we employed 40 people for good jobs and stuff like that. But sometimes it just takes that long for the technology to mature and then get caught up. And it's really very interesting now. You see some of these new head-up displays that are coming out, and Boeing is touted as one of the users in doing wire harnesses. Mm-hmm. You have these large wire bundles in airplanes. Well, we saw a demonstration of that by a guy named Meisel for Boeing in 1996. Okay. So they're starting finally now to use it on a production floor. So that's the challenge, is to keep the things alive, and ideally the lessons that were learned passed along. Because let me just tell you a little anecdote, which is, so we did something called the health kiosk. This is for older people who are living in a high-rise apartment, and they have to take their blood pressure periodically and so forth. So we had to build a system that the doctor could say, Miss Jones, we'd like you to take your blood pressure in the morning when you get up, or your pulse before you go, or your blood oxygen before you go to bed at night. And they could walk up to the kiosk, identify themselves with an RFID tag, and see what they had to do, and there's instructions there. As soon as they did it, the data would be sent to their doctor. Well, the nursing homes wanted to use a touchscreen because keyboard and a mouse would be foreign to people. But so was a touchscreen, so they didn't know you could actually touch something on the screen and something happened. So we had things like touch here. So they touched. Nothing happened. It's broken. I don't trust it. I'll never use it again. I'll tell my friends never use it again. Well, every software engineer in the world is looking for the release. But you told me touch, so they're very literal, so they touched. So when we changed it to tap, all of a sudden it started working, and it was the greatest thing around for this for the people. Mm-hmm. But you don't get those things in theory or in the lab. You have to, and now I'm seeing more and more user interfaces on smartphones and that they'll say tap. Mm-hmm. So they don't get themselves into that quandary as you get to the older generation that hasn't had the experience growing up with the technology.
Yeah, I mean, I just find that to be a really illustrative anecdote, in that my next question was going to be what you see as your responsibility as a technologist in communicating that. But it sounds to me, and maybe please correct me if I'm inferring incorrectly, that the user population is identified in much of the preliminary work that you do as you're developing a new device, whether it's the airplane mechanic or this group of individuals who really need to take regular blood pressure. Right. And that the features of the design, as well as how you communicate about that design, is really developed in the earliest phases before anything is actually built, by learning how to communicate with the user population. Is that the case? Yeah. So we do something called user-centered design. Mm-hmm. And the idea is you get your, I don't like the word stakeholders, but you get your people together. So in this particular case, with the health kiosk, we had the nurses, we had the patients, we had the doctors, and we start out and we create
a baseline scenario, a story with personas and that, a day in the life of. And then we create a visionary scenario of how technology might be able to improve that. And of course, we're checking with our customers as we go along. And then we create a paper prototype, if you please. Then we actually go out and build a physical prototype and install it and get some user feedback. So if you look at my table over there, we've actually run this class 25 times. And each time the students, well, and I'm talking about the quilt, but each time the students basically create an identity for themselves, create their own color scheme and so forth. So we surprise them with a t-shirt with their scheme at the end of the last day of class. And so we got the ideas. So I've got 3 quilts like this, which represent the projects. So every one of these projects had that type of lead up to it, working with end users and that. But the main thing is we do it in 15 weeks. So we have a functional prototype in 15 weeks. So we've done things like congestive heart failure. We did sclerosis last spring. These are braces that young girls have to wear to straighten out their spine, and they're uncomfortable and sensing the pressure and temperature and so forth. So we created a brace that was an active brace. And it's amazing, the students don't know what can't be done. So you end up with these incredible things, and every now and then, it's a good enough idea to start a company or something. But so that uses that user-centered design with the people engaged right from the beginning. And even if you don't get it exactly right, they're your champions for the rest of the community, because they know you listen and you're trying to do things with them and not ignoring them. Well, do you ever remember Clippy? Okay, so Clippy was this AI help you write documents tool with Microsoft. And Clippy would show up in a little, cute little paper.
A little paper clip.
Yeah.
I remember the icon.
And
yeah.
Most people wanted to shoot it because it was annoying as all get out. And so it's a very subtle thing. Again, we have a mantra in the Human-Computer Interaction Institute: user is not I. And Manny Powers, he make his students go out to Monroeville Mall, and you want to show your system, take it out to the mall walkers or somebody like that, people that aren't technical, because nobody on campus is typical.
Yes.
Typical of the population. And I think Microsoft maybe get into this, they often do their test marketing in Seattle. Well, Seattle's not.
It's not typical either, is it?
Yeah, and the people, and of course, what they give is prizes are next generation Microsoft software. So again, there's some self-selecting going on, and so you really have to get out to, who the mainline users are going to be. And we've preferred initially starting with the industrial area because they had, if you could save them time or something, there's a direct cost benefit that you could quantify, and people are quote unquote wearing uniforms, so you can make them use the technology, whereas when it's voluntary, you have to have a pretty captivative thing. You certainly see, different things, tweeting and stuff like that social media, some things have caught on like that, but the vast majority of things don't have that, user community, and so somebody's idea of what people would want, but usually it's not serving, the image, what other people want.
Mm-hmm. Yeah. Do you have any thoughts on how you think current AI systems will affect the way that people work in the coming 20 years? It's a difficult projection, but you.
Well, I can tell you what I would like for me. There's things that I do things in a somewhat repetitive way. So anytime something breaks at home and it's been a year or two since I fixed it, I start doing this problem solving all over again, making the same mistakes, and or like my windshield wiper. It's usually November when I realize it needs to be changed, but I don't know how I did it the last time. So I go and I fumble around and until I find, and then I'll forget what I did. So I'd like a system that looked over my shoulder and remembered the last thing I did and could remind me of that, as opposed to because there are just these things I do rarely. Things I do very repetitively as one thing. Now I'm not sure this is AI, but I see the workload, and my frustration goes up too. Is that everybody wants you to fill out their form on the web, and it makes their job easier, but you now have to learn their peculiarities. And for some reason, I tend to break things very easily or get into a state that they didn't anticipate. And I don't know what it is, but and that's very frustrating. So something
have you in the people that they were working with as they were designing.
Yeah, maybe I wasn't mainstream there or whatever, but
you have to start walking them all.
So there's just all kinds of examples like that where you get yourself into a catch-22 that you can't do this without that, but you don't have that, so how you do this? Just very recently, the Pittsburgh Post-Gazette went to electronic media, and they're not publishing paper 2 days a week. And so I had to finally activate my account. My wife likes the newspaper, and we didn't need the electronic version until now. And so it took me 45 minutes to find my account number, and it went through any number of, you get the answering machine, the robo or whatever it is, and they say press this, press this, press this, and I go through it, and they cut me off. They just drop me. And so, but that's the only instruction they give you, which probably increases their response time, I guess, or whatever. But so I always seem to have on these automated systems, either I'm thinking differently or something, but I end up taking probably 5 times longer to do things than if I did daily and knew about it. So I think those rare activities, the things I'd love something to, reach over my shoulder and tell me, you press the number 1 button. This is what hash mark is, or whatever. And I just need to know what I need to do. I don't need a big long list. Press 1 to do this, press 2 to do this.
Yeah, it's such an interesting shift in relationships, because it sounds to me that what you're describing there is actually it's a shifting power negotiation, right?
Yeah.
And so what you've shared in the development of these various systems that have been developed over 17 years, or even the short prototype practice with your students, really is putting emphasis on what the needs are in terms of what's articulated by a user population. It sounds to me in this example of the newspaper that the power negotiation has shifted, where the person, instead of using this as a tool, is kind of subject to the design features of that tool.
Right.
Can you talk about that a little bit?
Well, in the newspaper case, the thing is sort of blast through to get to a person.
Yes.
And then the person, now he couldn't help me, but he got me to the person that could help me, and then give me my account number that then I could now sign on to my web account to get the electronic version delivered to my mailbox. And if you knew what you're doing, it was 5 minutes. But if you don't know what you're doing and you run out of what you think are the obvious things, so I think it takes a certain critical mass to have enough people try things. And we haven't even talked about people with disability or color blindness or other things that naturally are assumed not to happen. But so there's one of our faculty, Jen Mankoff, did some work on evaluating your website to see if it was navigable by somebody who is blind, or our screen reader could make sense out of it. So often we don't have the people, some people that need the help the most, they're nowhere near the designers or nowhere near the experience of designers. That's why you see the assistive technologies that come out often are from people who either experience it themselves or they have a family member or somebody that they're trying to help. Oh, I'm sure there are ones, and they're probably so buried that we don't consider them AI systems anymore. But you know, so to some extent, you know, the automatic fill-in of blanks and that. Now, occasionally, it just bothers me. You know, if I tell it no the first time, it should learn. But so there's these things that automatically take strings and make them into web pointers. Well, there's sometimes I don't want that, but every time I put one in, I have to tell it no. So I guess there are things, but you know, they're better than Clippy. But at times they're frustrating. That you can't figure out how to turn them off. Mm-hmm. But there are certainly getting more and more of these things. Maybe they're doing minor functions, and you don't really think of them as an AI system. So I sort of liken it to take an automobile. Your automobile probably has like 60 motors in it, electric motors. Well, you don't think of them as electric motors. They pop the gas cap, they pop the trunk, they control the windows, the windshield wipers, and so forth. So you think of them as their service or their function. And I think that's, you know, what you're seeing with the AI systems. You know, the AI is buried inside, you know, Echo or something like that. And I mean, those are certainly still in their trial area, and you know, I guess weather and time are sort of the most often requested things, which is kind of expensive for just getting those two things. But you know, you've got to get enough out there so you get the imagination and the applications, because usually the platform developers don't really have a good handle on applications, and it takes somebody with a different type of thinking to see how they could use it in a different way. Well, I am concerned about a couple of things. I don't know the solutions to them. You talk about the automatic cars, self-driving cars. Well, the default seems to be, okay, when we don't know what to do, give it back to the driver. Well, I mean, if the driver's involved driving the car, he's going to be aware of the situation. But if you're chatting or something like this, and you know, it doesn't take much of a distraction. You know, they talk about cell phones or that, but even talking to somebody in the seat next to you can be enough of a distraction. Every now and then I just go automatic on which way I turn. My wife says, "Where are we going?" And because we were talking, I was going on my old habits. But if I'm not having those habits exercised, then my ability to become aware of the situation and figure out the right way to handle it. So I'm really concerned about, you know, totally automated cars. You know, there's things that, you know, like the automatic braking systems that have worked really, really well, and we don't even think of them. I guess you can think of them as an AI system. They probably were in the first incarnation, but maybe like my router type of thing is once you figured out exactly which the best way to do it, you don't need all the scaffolding of AI. You can just hard code the algorithms in.
Right.
But discovering those things needs a tool, and you know, AI provides a way of getting a lot of disparate knowledge. You know, working on the same problem. You mean in terms of financial gain or what? Well, I think of a couple things that's not necessarily related. So one thing I think we address it all is what I'll call garbage collection. You know, so we're going to have this Internet of Things, and there are going to be billions and billions of these things. Nobody's going to know where they are. Nobody's going to know what they're doing, and they'll be generating their own power. So they won't even naturally die. And so, a sample I like to give is the very early days of the space race. The U.S. is trying to put up a satellite using commercial rather than military hardware, and you had something called Vanguard. Well, Vanguard was a sort of a grapefruit-sized satellite, and it had solar cells, and the only thing it did was go beep, 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 just to show they could do it. Well, they forgot to put a shut-off switch. And so for 25 years, the important part of satellite wireless spectrum is taken up by beep, 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 beep. And so we're not putting shut-off switches. Some of these systems you might want to think that they should commit suicide after a while. So that, because I'm always concerned about unlearning things. I mean, the system may have learned something that was important at one time, but things change. And they're always talking about learning systems, but they don't talk about how do you unlearn.
Mm-hmm.
And so I think there's some challenges there, plus the fact that we got more and more of these systems, and we don't know how they interact, and we don't even know how to turn them off anymore. Well, somebody was telling me they just looked at a mattress or something ad, and then all of a sudden, every time they went to the web, they got an advertisement pop up for mattresses. And so, these things are sort of quote unquote free, but in order to be free, they've got to make money somehow, and so they're either pushing things at you or using your stuff to, create a profile or something. So there's an awful lot of stuff out there, even if you're not part of the social web, that people know about you, and exactly where that's going to go. I mean, we've already seen, theft of. So they were talking the other day. Apparently, a big scam nowadays is to, as soon as a newborn comes into the world, they get a social security number, and there are people poaching these social security numbers to get fraudulent claims. So they're saying you should get your newborn and freeze their account, but remember to tell them about it, because it may be 60 years later. But who's going to remember? So there's going to be these, I don't want to call them time bombs, but there are going to be these switches that are going to be buried, and we don't know what they are, and we don't know what they do. Are you looking at allocating responsibility, or something happens and who's responsible for it? I find this really difficult. Many years ago, there was a case about, I guess it was a power lawnmower, and somebody had, something had happened, and but the power lawnmower is a 20-year-old lawnmower. So at the time, it was built to every specification and safety measure that they knew about. 20 years later, they know a lot more, but you're still left with the old device. And so, and it caused a problem, but that if it was a new device, it wouldn't have caused. Responsibility for that? It's the same thing. You got all these things that are buried, and particularly if they're self-renewing, if you please, either energy-wise or software upgrade or protocol or whatever. There's an awful lot of things that are sort of done automatically that you don't even know are happening.
So if AI and computer science keep progressing more and more rapidly, could we face the prospect of a world where we have a lot of variegated, historic, intelligent machines around us, all built in their own decades, but all connected to us in data and in interaction with us? That seems messy.
Yeah, it does mean messy. I mean, it probably needs to be some discipline. Go back to the original TCP/IP or something like that. Where is the architecture anymore? There used to be people very carefully designing protocols, and they did a really magnificent job to look at how long they still are viable. But I think now more and more you get startups composing systems out of other systems, and so people talk about emergent behavior, things that can happen that you never envisioned, but in hindsight said, well, yeah, that's sort of obvious, but you didn't know those things were going to interact in that way. So I just hope that, power companies and other places that had their own proprietary networks, as they become more on the commercial network, that whatever discipline they had in terms of keeping their systems safe, continue that way. But I think we're going to just keep stumbling into new things and then patching things as we go along. Wow. Well, let's see, not in my lifetime, but AI has gone through these different phases, where we think we got it cracked and rule-based, and then we ended up against a wall of thousands of rules, and then statistical came along, and that was really great, but we didn't know what it was modeling, but we just give it enough data, it seems to come up with a good answer.
Now we got deep neural nets.
Yeah. So there'll always be this new fad or something, but it seems to me the systems that eventually are going to break out of the, let me say, whatever barrier there is, it would be, let me say, multi-AI-ish, or, multiple. There would be certain AI approaches that are good for certain things and other things. But I don't see anybody architecting that. And I think a good university project would be try to figure out what the architecture of these, call them composite or hybrid systems or whatever, but you got to figure out how they can work together. It's sort of like a population too, because you got people that all have different capabilities, but they somehow have to get along and still survive and still thrive.